Hi, my name is Roman Ebi, student in first year Master of Management Science with a specialization in finance at the University of Namur in Belgium. In this video, my colleague Pierre Capel and myself are going to discuss about a survey of the Interbank network literature, which is called Too Interconnected to Fail. It has been published by Anne-Caroline User, which highlights the mechanism of interconnection amongst the whole banking industry. This analysis is part of an assignment in our financial risk management class given by the professor Jean-Yves Niabot. We hope you will enjoy this presentation in this video, and I will let my colleague Pierre Capel explain you in details all the key points of the introductions. Enjoy.
We have seen examples like the 2008 crisis, where a shock absorbed by a bank or more generally an institution can have impact on other banks. There are thus networks with linkages between these banks. Through different key points of the survey, we will present several main ideas and answer a few questions related to relation a bank can have. But first thing first, let's begin with the plan of the presentation. We will start with a quick introduction and some basic interrogations about networks that the survey answers. We will then continue with questions around the network formation, how the links are created. Then we enter in the core of the paper with questions related to the purpose of these links, the different types, and finally how a shock can be absorbed by a network depending on its characteristics. We know with the example of the 2008 financial crisis that banks are connected with each other. The survey tells us that the best way to represent this relation is with networks. These are relevant for assessing financial stability and systemic risk. We can compute it by capturing the externalities that the risk associated with one institution may create for the entire system. These networks become very useful if we want to guide policy. In fact, it becomes necessary to measure the capacity of banks to generate contagion to the rest of the system. There are existing surveys regarding this subject, as you can see with these three examples. The problem is that there is no survey that takes stock of the recent new studies, so the present survey aims to fill the gap by providing a systemic overview of the theoretical interbank network literature. The survey also provides a systemic discussion of the policy insights from theoretical network models. More precisely, the survey takes stock of our current understanding of the topology of interbank network, how its structure affects contagion, and finally how banks form connection when faced with the possibility of contagion and systemic risk. They present for each aspect a quick overview of the results, avenues for further research, and provided and policy insight gained by interbank network. We can end this introduction with a basic question. Why can we represent links with a network? The survey gives us four main reasons as follows. The first one, network represent the fact that banks have heterogeneous balance sheet characteristics. Banks will be of different sizes and have different composition of assets and liabilities. Heterogeneous balance sheet characteristics imply heterogeneity in banks' inherent ability to withstand external shocks. The second one, link between banks are directed. Consider the simplest case where one bank lends to another bank. The first bank is exposed to the default of the second bank. It is the counterparty risk, while the second bank might be exposed to the willingness of the first bank to roll over the loan. It's the rollover risk. In both cases, the direction of the link does matter for economic interpretation. The first one is weighted link between banks are captured. A weighted link in this context means that links are associated with monetary quantities and transaction volumes. For example, a weighted link between two banks can represent the size of the interbank loans between those two banks. The fourth and the last one is different types of links between banks are also captured. Now we can represent it in recent research by a multi-layer financial networks, but we will speak about it later. Now that we've spoke about a network that can exist, let's see how their formation is made. First, it has been pointed out that the trust between banks between themselves is a key driver in the formation of interbank relation. We also saw that each bank chooses its interbank relationship to get the highest expected possible rate on the funding it lends out and the investment it undertakes. The bank with the highest expected returns become intermediaries. It means that they are borrowers and lenders at the same time. By this position, they play a central role in holding together the interbank market. Those banks are the ones who make the risky investment and that are over-connected. It leads to a higher counterparty risk, of course, the risk we spoke about just before that. But other banks want also to have the highest possible returns, so they choose the short connecting path to avoid paying some intermediation spread when it is possible, of course. Those banks mainly provide funding and end up with too few connections. We were speaking about the counterparty risk just before. There is a problem linked to this. Banks take the impact of their action on their direct counterparties into account, but fail to internalize the externalities that they impose on the rest of the financial system. It can lead to an overlending in equilibrium. The structure that we've just saw hereover may imply a scale-free structure. It means that it might not be representative. Indeed, we have a few banks with many interbank connections, and many banks with just a few links. The network we are describing here leads to a core periphery equilibrium network, where the core of the structure is the bank with the risky investment. A core periphery equilibrium network appears when the banks in the system are partitioned into two sets based on their bilateral relation with each other, which is what we've just described. This structure is founded on intermediation, as we thought with the core banks that are special intermediaries and that play a central role in holding together the interbank market. So we are clearly in this type of equilibrium here. This incentive structure leads to high systemic risk on the asset side, as we have correlated portfolios, and on the liability side, because there are many direct interbank exposure. There is not just one type of relations between banks, so we needed a system that takes into account the different type of relation and not just consider one type. This is why a more realistic representation has been developed, which is the multi-layer interbank networks. We briefly spoke about it before. It's composed by a series of layers. Each node is a bank and each layer is a network representing one type of relation. For instance, you can have maturity, nature of the contract, instrument, and so on and so on. We've spoke about the systemic risk. We can make here a little parenthesis, as the central bank can play a role in this systemic risk. The central bank intervention can affect market liquidity and the systemic risk, as we've just said. For instance, increasing liquidity can lead to banks that are more resilient to adverse shock. The central bank can put some requirement in place. We will briefly speak here about the liquidity and the capital requirement that can lead to a reduction of this systemic risk. First, the liquidity requirement. The first one is a uniform increase in liquid assets holding, and the second imposes an increase in liquid assets that is positively related to banks' interbank assets. showed that increasing liquidity requirements for systemically important banks and reducing it for the others could lead to lower the systemic risk. Now, about the capital requirement. It has been shown that better capitalized banks are more resilient to adverse shock, as we said. So, the central bank put in place a requirement for a higher amount of capital that financial institution has to hold in order to face those adverse shocks and being able to face the systemic risk they imply. This is it for a little parenthesis. Now, Romain will explain you how network structure affect contagion.